Hello students. So let's try to solve one more problem from Jest 2021 exam, and it's a problem from quantum mechanics, mainly from simple harmonic motion. So problem is very interesting. So it is given that there is a harmonic oscillator. So we can assume that my harmonic oscillator is half m omega square x square. So this is just our assumption. So that will be half m omega square x square. Now, and it is given for the ground state, the uncertainty delta x is given as something like 2 h cut upon mc, and this is for given for ground state, means n is equal to 0. And what we have to do, we have to find how much energy. Suppose this is my oscillator, this is my oscillator. So this is ground state, this is first excited state. So the energy for ground state is obviously h cut omega by 2, and energy for first excited state is 3 by 2 h cut omega. So what we have to find, we have to find how much energy needed such that particle will excited from ground state to first excited state, and we have to express that energy in term of, so this is delta E energy, and we have to express this energy in term of mainly mc square into 10 to the power minus 4. So we have to express this particular energy something like this, and we have to, some value is alpha, so we have to calculate this particular value of alpha. So question is very straightforward. What we have to do, we have to use this expression, and from this expression we have to find the value of omega or h cut omega, and we can use here directly. So obviously, suppose my potential is half m omega square x square, then we need energy, that energy is equal to such that particle will move from excite from ground state to first excited state. So that value is 3 by 2 h cut omega minus h cut by 2 omega, that is h cut omega. So basically we have to write this value of h cut omega in term of alpha mc square into 10 to the power minus 4. So how we can write this particular thing? So let's try to calculate the delta x. So for the ground state, and it is delta x for the ground state is given this. So obviously the expectation value of x in a ground state or in the nth state we can calculate. In the nth state is given by n a plus a Dagger n, and obviously we have some parameter h cut upon 2m omega root under, where x can be written as a plus a Dagger into this parameter h cut upon 2m omega. So from here we can calculate the value of x, and fortunately we can get the value of x is equal to 0, because expectation value of a on any state n is 0, expectation value of a Dagger on any state n is 0. So expectation value of x is 0. Similarly, we have to calculate the expectation value of x square. So when we are going to calculate the expectation value of x square, and that value is n a square a Dagger square and 2n plus 1 into h cut upon 2m omega. So we can easily calculate this particular thing. So this is the value, and obviously we have expectation value of a square is 0, a Dagger square is 0. So average value of x square is basically 2n plus 1 h cut upon 2m omega. Now for the ground state, in the expectation of x is 0 for any state, and for the ground state n is equal to 0, we have expectation value of x square is h cut upon 2m omega. And in this particular problem, it is given that delta x is this much for the ground state. So let's try to use this expression that delta x is given by root under expectation value of x square minus expectation value x whole square, and that value is actually for the ground state x is expectation of x is 0, x square we can write from here. So this value is h cut upon 2m omega root under, and this value is given as basically 2h cut upon, so this value is 2h cut upon mc, and this value is h cut upon 2m omega. And now we need to calculate the value of h cut omega into mc square, and this is basically root square. Root is there. So what we can do, we can take the square both side and we can easily calculate the value of h cut omega. So when we are going to take a square on both side, then we have 8 h cut square upon m square c square is equal to h cut upon 2m omega, and we can remove this particular value. So if we are going to remove this particular thing, so one h cut is gone, one m and one m is gone, so this 2 will be there, so this is 8 is there, 4 into 2 is 8, so we have h cut into omega is equal to something mc square by 8. Now we can write this h cut omega. So this is the change in energy. This is the required energy for which your particle will go from ground state to first excited state. So now we can write this h cut omega as mc square by 8. This is the value of h cut omega. Now we have to write this thing. We have to write delta E in this particular term. So what we have to do? We have to multiply with 10 to the power minus 4. Then we have to divide with 10 to the power minus 4. And this value is 10 to the power plus 4 by 8 into mc square into 10 to the power minus 4. So this typical value will come out of, you can easily calculate, this particular value is 1250 into mc square into 10 to the power minus 4. So answer is, so your answer is 1250. So this is a typical answer. You can easily calculate this thing. So it's a very nice problem. Everything is given into this problem. You have to just practice how the raising operator and lowering operator can work together, how delta x is there. But the most important thing is that how you can incorporate the parameter h cut omega. The parameter h cut omega is the most important thing for harmonic oscillator. So it's a wonderful question and you should practice it in a very nice manner. Thank you.